Hi, I'm Walton McCarthy. I'm the author of Principles of Protection. I will be reviewing the POP in 32 sessions discussing all aspects of underground shelters. I've been in the field of underground shelters for over 43 years as a mechanical engineer, and most of my work has been with military shelters or corporate shelters to protect key executives. So we'll review this first session based on nuclear weapons. A lot of what I've done in the past has been on structures that can be used in severe environments, made out of steel or made out of composite, because the composite is radar transparent. I formed a technical committee back in 1978 when I got private funding to write the book. And the technical committee is made up by key people in the government and private industry. For example, Dr. Chilton helped me with radiation entranceway shielding. He's an expert in that field. He does that for the military. Dr. Lewis Spencer, National Bureau of Standards, his expert is radiation transport and mechanical review for structures that are underground and subjected to military to weapon effects. So these people spend lots of time with me to make sure that I've got the data right and that I presented it, and I'm trying to present it to the layperson. So the first session is on weapon effects. The data that I use in here are for weapons that are 50% fission and 50% fusion. The Bible in the industry for the effects of nuclear weapons is called E&W. And this is a book that's now published by Department of Defense. The original edition was 1945. The most recent edition is 1977. So that's the one that we'll be using. The editors for this book is a really technical book. It's not designed for the layperson. As a mechanical engineer, I struggle with a lot of it. So I met with Dr. Samuel Gladstone and Dr. Philip Dolan. These guys are brains. They are way above the PhD level. I mean, they're on another planet, and they were great. So they helped me with a lot of this to get the data, to get the progression of weapon effects right. It was a very big deal, and I'm very grateful that they can work with me like that. So here's what you base a shelter design on. This is the effects from a 100 kiloton surface burst. These are the actual effects based on the Delphic model, the actual effects from nuclear weapons in the Nevada test site. Now, in POP, there'll be other tables, from 50 kiloton, 500 kiloton, 1 megaton, and you can use that if you want. I usually use this because this is the most common weapon in this time. There used to be megaton weapons, but because the 10 megaton weapon doesn't do 10 times more damage than a 1 megaton weapon, everything is back in the kiloton range, because you can take a 1 megaton, break it up into 10 100 kilotons and do 10 times more damage. It's just math. So when you start out designing a shelter, you're going to pick a distance from ground zero and an overpressure. So most of what I work on is 15 to 20 psi overpressure, and that happens at a certain distance from ground zero. In this case, 0.7 miles for a 100 kiloton weapon. And then you can see the other weapon effects here. Neutron radiation at 0.7 is 15,000 rems of neutron, 9,554 rems of gamma, 4,500 rems of initial gamma. So this is what you're designing a shelter for. The radiation dose is, of course, affected by the shielding. But if you look at the other thing that's important to point out here is look at the decay rate from week 1 to the second month. Even at 0.7 miles, you're getting 1,240 rems a day. The lethal limit is 200 rems if you have medical help. If you don't have medical help, it's probably 150, 120. So the way that it decays, it's really radical. By the 5th week, even at 0.7 miles, you're down to 3 rems a day. If you're 100 miles away, you're down to 0.1 rems a day. So what this is telling you, what all this is telling you here, is that after 30 days, the radiation has 99% of the radiation has decayed. And you got to be careful about that, because you hear that the half-life of radiation is thousands of years, but it's not properly properly understood, because if you spill gasoline on the ground, you can find those constituents 1,000 years later, but it's not volatile for all those years. So you got to be careful here. But so that's a key part of this. This is where you're going to get the overpressure. This is what it's based on. So when you design a shelter, a rated shelter, it's going to tell you the distance from ground zero from a certain size weapon at a certain overpressure with a certain radiation dose, and it'll tell you what's happening inside the shelter based on shielding. The other important thing here is, if you look at this, for example, 1 mile, the overpressure PSI is 8 PSI. If you go to the 10 megaton table, at 2 miles, it's 9 PSI. So even though you've increased the weapon tenfold, the radius has only increased for that pressure to 2 miles. It's not 10. So when you hear that we can kill everybody on the planet 7 times over, it's because they're taking the fatality rate based on a 100 kiloton weapon, and they said then therefore that a 10 megaton weapon, 100 times bigger, can do 100 times the death rate, and it doesn't work like that. So that's one of the misconceptions. But these tables you're going to be seeing a lot of. It's going to be in virtually every session, because it all comes from this. So this is just an introduction. We'll be talking about these, but don't be afraid of this table.